Hello, welcome to the fourth webinar about search and swab during connections. My name is Dmitry Gorsky. I am a CTO of Heave Solutions. We're a specialized consultancy company based in Trondheim in Norway, and we specialize in simulating search and swab and its effect during connections and tripping for floating rigs specifically. And today's webinar is going to be a case study. We have invited Johannes Ladenhauf, who is a senior engineer with OMV Norge, and he will be talking about using our simulations on Hades Iris prospect and the potential of such use.
Hello, my name is Johannes Ladenhauf and I work as a senior drilling engineer for OMV Norge. OMV was drilling a vertical HB/HT exploration well in the Haltenbanken area in the Norwegian Sea during winter 2017-2018. The chosen rig for this operation was the semi-sub Deep Sea Bergen. OMV knew that winter operations in the Haltenbanken area possibly means rough seas and extensive weather-related downtime. The well was planned with a rather conventional casing design, and drilling of both reservoirs, these were stacked reservoirs, was planned with 8.5-inch bit size. Finally, the lower Iris target was found to be of even higher bore pressure than forecasted, and so it was decided to run a 7-inch contingency liner and case off the upper hardest part of the reservoir. This is a rather important information when we discuss the concept of dynamic rig heave limit and why it's important to calculate it. As a part of operations planning and to get a more fundamental understanding of heave impact on the well design, OMV did a study with a Norwegian research institute up front before drilling the well. This study presented a set of maximum variation in downhole pressure, peak-to-peak values for various heave amplitudes and heave periods with specific PHAs at specific depths in slips, and the string is not heave compensated. Such a study is a valid way to get pre-drilling indication about what heave is doing to your wellbore pressures at critical depths. This was all done pre-drilling in order to assess the possible impact of heave on our wellbore pressures. But how did it actually look then like before drilling? So what is this slide showing us? First of all, it can be seen that heave is dramatically impacting downhole pressures. These data were recorded during fingerprinting operations before drilling out the 8.5-inch reservoir section. It represents pressure while drilling downhole memory data. On the y-axis, we can see absolute pressure, and on the x-axis, it's time. So during all these operations, the string was static, not heave compensated in the rotary table. While pumps on, the heave impact was plus minus 35 bars, and while pumps off, the heave impact measured downhole was plus minus 19 to 24 bars max. Looking back at the pre-drilling study, these values matched the prognosed values almost on the spot. However, since OMV got confirmation of the simulations and was now even more aware of the heave impact on such wells, we investigated an option to see if we can estimate the heave impact more on the fly rather than upfront with a study. This heave impact on the fly should adapt to the current drilling circumstances as well as PHAs, well depth, and maybe also changing borehole configurations. We got in touch with Heave-Log and asked them to do a post-study for this very same well. The major and very important difference between the first study and the one done by Heave-Log is the dynamic rig heave approach Heave-Log presented to us. So what is this dynamic rig heave approach Heave-Log presented us? It's basically a roadmap for rig heave limits. Looking on the left side, the blue line represents this rig heave roadmap for our 8.5-inch section in the Iris Hades well, which I presented you at the very first slide. This roadmap takes into account well geometry, PHA, mud, pore, and frac pressures over a full well interval. And it's basically a total picture of the well and when to stick to which limit. As you can see from the roadmap on the right side, the rig heave limit is varying a lot over the simulated 8.5-inch interval, mostly driven by the available mud weight window. We had one very bad winter storm which hit us right at the beginning of the 8.5-inch section, and we experienced heave values of up to 10 meters. The graph on the right shows the heave development over time during this storm, and having access to Dynamic Rig Heave limit would have saved 2 days of wait-out weather at the end of the storm, where our heave limit would have been at least around 5 meters according to the graph. We could have resumed 2 days earlier by just knowing about the rig heave margin the well could take at the beginning. So this roadmap could have basically saved us a lot of money. This statement is for sure neglecting any rig-specific limits, but purely looking on the well bore, we could have afforded a 5-meter heave limit.
Thank you for listening. We have been working with OMV Norge for about 2 years now. They have a relatively small but very capable drilling and well organization in Norway, and they are active in such regions as the Norwegian Sea, where you have a lot of harsh weather coming from the open ocean, and also up in the north on the Wisting prospect, which is coming in a couple of years, where geology is rather demanding. We're looking forward to working with them further in the years to come. And our next webinar is a case study from Norske Shell, where Knut Hals, the team lead for completion in Norske Shell, will present how they used our simulations during completion operations in an infill well on Knarrfjord. See you then. Thank you.